Welcome today, and we're going to be interpreting functions. And I'm your teacher, Pickle Rick. So, Pickle Rick says, read that. This is your answer choices. And these answer choices, we're going to mark them as true or false. So, we're trying to read this situation and then interpret these as true or false. So, let's just jump right at it. You've had time to read it. Talking about the height of rain, the height of a river after rainfall. So here, 9 has replaced R. So whatever R represents is what the 9 represents. R represents the amount of rainfall. So 9 represents 9 inches. So where it says H at 9 equals 32, what does this truly mean? It means that after 9 inches of rain, so we established here it's 9 inches of rainfall, the river is 32 feet high. So is the river measured in feet? Yes. So this is true. So this first one here is true. H at 0, so at 0 inches of rain, it's at 14 feet. It's what this should say. It's what it should mean. So they're saying it means the river's starting height is 14 feet. Well, if it's at 0 inches of rain, that's where we started. So that is also true. And our bottom one, if we take the height of the river at 15 inches and subtract the height of the river at 10 inches, it should equal 20 feet. So this means that the river raised 20 feet between 10 and 15 inches of rain. So again, if I subtract the height, we'll use a thing here. So this is the height. So there's at 10 inches. Here's at 15. If I take this away from that, it should give me this extra amount that it increased, which they're saying is 20 feet. So did the river raise 20 feet between that? Yes. That is also true. And you can't question it because, listen, I'm not the nicest guy in the universe because I'm the smartest, and being the nice, it's just something stupid people do to hedge their bets. Rick said he said it, but I'm Pickle Rick, so I'm right. Here we go. Read the situation and interpret the linear function. So, there's a y-intercept at 65, and then a minus 55t slope. So in this, we're talking about distance in miles that she is from her house. So if you hadn't figured it out, let's look at it graphically. So distance from house in miles that she is after hours. So hours determines the distance from the house. So looking at it graphically, we start up here at 65. And every hour, this should be going down. So after 1 hour, we should be at 10 away. I'm way off drawing that. And then somewhere between 1 and 2 hours, it should hit. We should get home. So, which is correct? 55 miles away from home? No. 65 miles away from home? Good. This said 55 from home, so I know that's right. So these are both 65. When she starts driving, she's driving towards her house. Here it says driving away. Again, represent the distance, the miles that she is from her house. So if it's going down, we're getting closer to the house. So she is driving towards her home. All right, here we go now. Same like the first one, you've had time to read it, so I'm going to go ahead and just answer. At the beginning year, it was 3 feet tall. 3 feet tall when it was planted, true. 6 years, it is now 9 feet. In 9 years, it is 6 feet, so that one's false. If we subtract the height in 20 years that it was in 10 years, that means it grew 42 in between those. Means the series grew 42 between 10 and 20, so that is also true. It's a lot of reading. are very, very wordy. Alright, here we go. Same thing. True, false, true, false. So, C represents cars sold. Sold 10 cars. Is it to $20,000? Well, I can plug 10 in up there and know that this is true. Because I actually gave you the function up there. If he sells 2,000 cars, does he get, whoa! If he sells 1 car, then this is true? No, it should be flip-flop. That's false. If Bill sells 5 cars, then selling 5 cars equals 10,000. Well, 5 cars, they're 2,000 each. That is also true. And next, this is a very short video, just reading and practicing stuff. Federico! I know him. That's the guy. Remember in a video a little while ago we had a guy chilling over here I thought was Ramsey on a diet? Man, that wasn't Ramsey. That's Federico. That's some dude. I mean, he said he was Coach Ramsey, and I fell for it. I mean, they looked almost the same. But this guy was a little shorter. I don't know how I didn't see that. This is weird. Anyway, read this, answer this, hit timeout, now time in. Let's do it. At the end of the first day, 33. So what does that mean? Well, at f of n is what the 33 means, because n was replaced with the number 33. So, where does it say n at up here? Come on, pop out at us. The function f of n and the amount of money in dollars he earned selling n number of subscriptions. There it is. Boom. So this is 33 subscriptions, so he made $66 that day. So our question is, what's the total number of subscriptions he sold on the first day? Boom, 33. So again, you're looking at function notation here, trying to interpret these things. Very wordy questions for EOC, TCAP, and other things. All right, here we go. That's what the question ends. You got ABCD. Go. All right, which is true? Every real number can be used as the value of t and we'll define the value of h of t. Well, can we always use every number? Is every number always used in every function? No, we can't prove this. We can't really prove that. Is every value of t in the domain will generate a value of h of t such that they're never equal to each other. So that means if x is 1, I can never have the output as 1. That's not always true. I can't prove that. So every value of h of t, that's your y value or output, in the range is generated by only one value of t. Oh, my friend, that is close to right. But h of t, the y value, the range can repeat. The different inputs can produce different outputs. So that is, so close. Each value of t, each input or x or domain, generates only one output. That is true. That's the definition. Each input generates only one output. So D. It's just written a little different. Abstract. And select all that apply. One of them. Alright, so X represents the number of miles driven. So, which one of the following questions can be used to calculate the total daily cost of renting a car? It's 18 cents per mile driven. And it's saying for renting a car, the days aren't going to repeat because we don't have a variable to multiply the days. But we do have a variable that multiplies with the miles driven. So 0.18x is not there. 1800's x, 1800x, nope. They put them together. That is not going to happen. So now we've limited to 3. But x should only be with that. So that doesn't make sense. Again, x should only be with the... So there's our only answer that works. If I were to write this function, I would have probably written y equals what it costs to start with to rent it. And then I'm going to add on to that the price they charge me per mile x. Well, this doesn't even look like it. And it comes back to those equivalent forms. Can I minus 24 here, and then minus 24 on this side with my equal sign? Yeah, we'll get my y minus 24 is equal to, oh, typo. Federico's messing with me again. And now we have this one. So there's only one answer out of the select all that apply. I hate those. But I'm Pickle Rick, and you got two left. So a rock is tossed off a building, okay? And there's a function. It describes that height in feet of the rock t seconds after it's thrown. Something's wrong with that. If I kicked it, how did I throw it? Or did my foot throw it like a kick? Using my monkey toes and stuff, just throw it with my foot. It's kind of like a kick throw. So what is the height of the rock 3 seconds after it's thrown? So seconds is the number 3. T seconds. So in this function, I'm going to put 3 right there and calculate it. So negative 16. So instead of t squared, I'm going to put 3 squared plus 42 times 3 instead of t plus 60. Then you type it in your calculator, you will get your answer. Voila. Final one. Don't pull nothing thinking about this answer. I'm not going to hold my breath that you got it already. That's right, because I'm like the smartest guy ever. I'm Pickle Rick. I got a quantum carburetor. Alright, so to visualize this one, since you've struggled with it, let's just view a gallon right here. I'm not good at drawing. So there's a gallon in that cylinder, which is really horrible. Because they don't look nothing alike, really. So yeah, you got this. So our function is going to be set up as the fuel remaining depends on the number of miles driven. So here's the fuel. This is, we'll say it's a gallon. I know it's not. So just use your imagination, squint back, or get really close to it and make it look bigger. So now you can think it's a gallon. If you just block me out, you won't know the difference. So you have 24 of these, and your fuel efficiency is 30 miles per gallon. So after 1 mile, have you used this whole gallon, or have you used a fraction of it? You use a little bit. So each mile, you're using a little bit of a gallon. So we start with 24 gallons, and we're using it at a rate of 1/30th every mile. 1/30th of a gallon every mile. And there's your final answer. This is just some wordy problems with functions, just to kind of help you see what we'll have on our possible EOCs or ACTs and such.